Hi, hello. Uh, okay, so today I will present one of the missions that we are planning here at Nihon University for lunar exploration. So let's start. The next, please. Okay, so this is just a picture to represent what is been achieved so far in Earth orbit by micro and nano satellites. So it's a comparison picture. On the left side, most of the missions have been relatively successful, developed several missions in the past 10 years. However, the same picture we want to achieve in the moon orbit in the next couple of years, starting probably from 2 or 3 years from now. Uh, so the big question is how to move the micro and nano satellite ecosystem into the lunar ecosystem. Uh, Next, please. So some of the major achievements for Earth exploration based on nano and micro satellites is because there are a vast amount of applications so far. There are regular replacements for the spacecraft, so those micro and nano satellites usually spend between 2 to 3 or 5 years in orbit, and this provides a rapid evolution of the systems on board, so which achieve let us achieve the mature system ecosystem. And of course we have to count for the transport infrastructure. So nowadays there are many transportation systems that are available for micro and nano satellites, uh, and even there are more under development. So I think the transportation infrastructure is also pushing up the space environment for nano and macro systems in space. So this ecosystem growing is also based on the very well understanding of space environment on both sides, in the physical and in the business perspective. So this provides an input for more players, and it's like a circle that is continuously growing. So the same environment is what we are looking forward for the next moon projects. So, but however, there are many questions. So far only big missions are able to develop missions on the moon. There are large transportation systems because the distance to the moon is uh, relatively very high compared with Earth LEO orbit, and only large space systems can provide these services. But the next step after going from Earth to the moon or and beyond is transportation, reutilization, and of course, a recovery of these materials. And nanosatellites are need to go to reach these steps, so they can provide the same the same advantages that they have provided so far in Earth, but now going to the moon and beyond. So the next one, please. Just to quickly have an overview of what is occurring on the moon. Next one, please. Next slide. Okay, so uh, at lunar orbit, we are targeting mainly two possibilities. So one is the one of the Lagrange points, and the other is the orbit around the moon. And this is because many of the services that are visionaries in the next years are based on propellant depot servicing, test beds, mining, science missions, communication services. However, there are many constraints and requirements that put a lot of pressure on the nano and micro systems. Some of those are related to communication links, the station keeping and navigation, power, and of course the satellite mass and size. The next one, please. So this is just an example of some of the constraints related with communication. So in order to communicate with a system on the moon, we require on the ground and on the satellite a bigger antenna in order to achieve the margin required for a reliable communication, and also the power on the transmitter side. This is in the satellite to provide a downlink communication channel has to increase. So some people have been doing some research on this, and they have came out with one of the best solutions, and of course, based on a trade-off, is using X or Ki-1s. So if we want to go to the moon and achieve reliable communication with a significant data rate, so we need to go for one of these two bands of communication. The next one, please. Okay, so another issue is regarding the station keeping. So in order to stay on the moon orbit, we require also significant delta V. So first of all for the injection orbit, and second of all for the station keeping. So we can see that also there are some research based on this and several studies, and they came up that in order to achieve a halo orbit in moon orbit with approximately 15 to 35,000 kilometers, so the delta V expected is between 42 to 100.5 meters per second, and that's only for the orbit injection. So propulsion system is also another big requirement, which in terms of power and size is also very important and significant for a micro and nano satellite in order to go for this type of orbits. The next one, please. Okay, so due to these constraints, we have visualized that there will be a necessity for increasing autonomous of operations. Also, we will have to be able to increase the reliability and reduce the mass low enough in order for the propellant to be the right amount of propellant to maintain orbit, and also to inject the satellite into the desired orbit. So based on these requirements and constraints, we envision that some parts of the key subsystems and parts that are required for this type of missions are based on onboard computing process capability, which we applied also for the navigation controller and EPS controller and payload controller, and also being able to keep the structure as low as possible to provide more payload and propulsion capabilities. And another important consideration is precision keeping, precision timekeeping. So we are basically going for the qualification and looking for the right standards or right group of standards in order to have a balance between the system level performance and the qualification requirement. The next one, please. So far we are facing the development of a lunar orbiter. So we are considering a 6U CubeSat for researching the space environment around the moon. We also want to perform research on the shielding capabilities of some protection materials. And our main objective is to strengthen and broaden the knowledge of the small sat technology for going to the moon. This is just a concept of our satellite, so which is based in a 6U satellite, and with most of the subsystems located in the core or the center of the 6U structure, and providing enough power and providing enough mass storage for the payloads, and also mass storage for propulsion system. The next one, please. So basically, we are looking to go into the observation system. So we will be able to provide also information and simulations. And the main objective is to provide in situ measurements and reduce the uncertainties in lunar hazards. The next one, please. So we have three main missions. One is testing multi-core processor capabilities. The other is a radiation experiment based on different experiments that we have carried out in space in Shinen2 and Ten-Koh satellite. And there is another proposal for testing space weather environment in the moon. So we are just under consideration with possible partners. The next one, please. And based on our experience with these different payloads, we are in the process of defining very well the goals and the development of concept of operations. So we have a group of sensors and payloads that we are been testing in previous mission, and we will have to make adjustments in order to equip this into the lunar orbiter. The next one, please. And currently, we are developing Ten-Koh 2 satellites. So Ten-Koh 2 satellite will provide degradation observation and 3D printed materials, which also help us to reduce the weight of the structure and internal parts. We will be testing some amateur transponder and a special camera for high-resolution pictures. And we want to apply this knowledge and to take the heritage from previous missions such as Shinen2 Ten-Koh and Ten-Koh 2 into a future mission will be Ten-Koh 3, and the next one and end one will be the lunar orbiter. So that's all from my side. Thank you very much.
ありがとうございました。質疑応答に移りたいと思いますが、今ないのと、時間があまり残りがないので、こちらで終わりにしたいと思います。Mr. Fajardo, because time is running up, we are going to finish now. Thank you very much for your presentation.
Thank you very much.